Welcome dear students. This is a very important topic related to the benzene, and that is the effect of substituents on further substitution. As we have already discussed that benzene is a regular hexagonal molecule and all the six corners of the benzene they are equivalent. So because all the six corners are equivalent, so hydrogen from any corner of the benzene can be replaced with a substituent, and you will get a monosubstituted product when a single substituent is added to the benzene. And only one monosubstituted product will be produced, as changing the location of the substituent on the benzene ring will not change the nature of the product, because all the six corners they are the equivalent ones. So benzene can give only one monosubstituted product. But my dear students, if a substituent is already present and you want to replace another hydrogen of the benzene ring with some substituent, mean you want to add the second substituent to the benzene ring, then my dear students, there are three options. First of all, let us discuss this very important point, that the corner with which the first substituent will be attached, that will be the reference corner, and it will be positioned as 1. And then, my dear students, as all the corners are equivalent, so you can start numbering either clockwise or anti-clockwise. I have mentioned the numbers clockwise here, that this one is the reference position 1, this one is 2, 3, 4, 5 and 6. Because all the corners are equivalent, so the corner number 2 and corner number 6, they should be equivalent ones, and they are called as the ortho positions. Similarly, the corner 3 and 5, they are equivalent and they are called as the meta positions, and the corner 4, that is called as the para position. My dear students, the second substituent may get attached to corner number 2 or corner number 6. Both products that will be same and they will be called as the ortho products. If the second substituent gets attached with the corner number 3 or corner number 5, these two are called as the meta products and they are the equivalent ones, they are the same. And if the second substituent gets attached to position number 4, then that is called as the para product. So there are three options. The two ortho products can be produced, or meta products can be produced, or the para product can be produced. My dear students, the first substituent which is already attached with the benzene, that is very important, because it has two major effects on the benzene ring. First is the direction effect, which is also called as the orientation effect, and the second one is the activity effect. Now, my dear students, if we talk about the statistical data, on statistical basis, there are 5 corners on the benzene if this first corner is considered as the reference corner. And out of the 5 corners, there are 2 ortho corners. Out of 5, there are 2 meta positions, and out of 5, there is only one para position. So, on the statistical basis, there are 40% chances of the second substituent to form the ortho product. There are 40% chances of the formation of the meta product, and there are 20% chances of the formation of the para product. But my dear students, it is not true in all the cases. So these statistical basis, they are important, but they are not true in all the cases. Actually, the first substituent which is attached with the benzene, it decides the orientation effect, it decides the activity of the benzene, and where the second substituent will get attached to the benzene, that is decided by the first substituent which is already attached to the benzene, and this is called as its direction effect or orientation effect. And how faster the introduction of the second substituent to the benzene ring will be, it is also decided by the first substituent already present on the benzene ring, because that first substituent can activate or deactivate the benzene ring. If it is an activator, then the introduction of the second substituent will be faster, as the activity of the benzene that will be increased. But if the first substituent is deactivator, then my dear students, the introduction of the second substituent, that will be very slow. Why? Because of the deactivation of the benzene ring. Now, due to orientation effect of this first substituent, there are two types of the directors. One are the ortho and the para directors. Let us understand what is meant by the ortho and para directors. My dear students, suppose that OH group is attached to the benzene and this one is phenol. Oxygen has two lone pair of the electrons. One of these lone pair gets involved in resonance with the pi bonds of the benzene. And my dear students, look at this now. Resonance starts between the lone pair of the oxygen and pi bonds of the benzene. The negative charge is delocalized, so it will keep on moving on the benzene ring. Something like this. And the resonance will be there between negative charge and pi bond of the benzene. Finally, the lone pair of electron, they will move back to their original position, that is the oxygen atom. And in this way, these are the different resonance structures. This one is the first one, it is second, it is third, fourth, and fifth. And in all these resonating structures, there is one point that is very important to note down, that the negative charge comes either on the ortho position or on the para position. Meta position remains electron deficient. So my dear students, this OH group, it has donated electron to the benzene ring. So I will say that it is electron donating group. And when it donates the electron to the benzene ring, you can see that benzene ring becomes electron rich, its nucleophilicity increases. It means that the activity of benzene that increases and its nucleophilicity also increases. And what will be the effect of this group? My dear students, if there is any electron donating group attached with the benzene ring, it makes the ortho and para positions electron rich. Once the ortho and para positions, they become the electron rich. So my dear students, the second substituent, which will be an electrophile, it will be automatically attracted towards either ortho position or the para position. And in this way, this electron donating group will be ortho and para director, as it has directed the new incoming substituent towards the ortho and the para positions. My dear students, there are so many examples of the ortho and para directing groups, just like OH group, NH2 group, secondary amine group. Similarly, all the alkyl groups, and similarly all the halogens. They are all the examples of the ortho and para directors. And my dear students, usually ortho and para directors, they are the activating groups, so they are called as the activators. Now these three, as the key atom is the one which has unsatisfied bond and it will get attached to the benzene ring. As the key atom has lone pair of the electron, so these three, that will be strong activators. The alkyl group, you know that the carbon, just taking an example of the methyl group, carbon has no lone pair of the electron, but here a process of the hyperconjugation or no bond resonance starts, and that's why they donate the electrons to the benzene ring and they make the benzene ring more reactive towards the electrophiles. So they are basically weak activators. And my dear students, halogens, that is an exception, that the halogens are ortho and para directing because their lone pair of electron that resonates with the pi bond of the benzene ring, but they are basically deactivators. Now the question is why the halogens are deactivators. My dear students, suppose that this is the benzene ring and with this benzene a halogen atom is attached. Every halogen atom has three lone pair of electron. So one of the lone pair of the halogens that will get involved in the resonance with the pi bond of the benzene ring. So that will be called as the positive resonance effect. But you know that the halogens are highly electronegative, so they will also withdraw the electrons from the benzene ring, and that will be called as the negative inductive effect. Dear students, in case of the halogens, the negative inductive effect dominates the positive resonance effect, due to which instead of making the benzene ring electron rich, the halogens, they make the benzene ring electron deficient. And once the benzene ring becomes electron deficient due to the withdrawing effects of the halogen, its nucleophilicity decreases and the reactivity of the benzene also decreases. So the halogens, they are basically deactivators, although they are the ortho and para directors. My dear students, the second category is of meta directors. In meta directors, let us take example of the nitrobenzene. This is the nitrobenzene in which nitro group is attached to the benzene. Now this nitrogen is electron deficient because it is attached to two highly electronegative atoms. So instead of donating electrons to the benzene, it will start withdrawing electrons from the benzene. And my dear students, now again the resonance starts, and now instead of negative charge, there will be positive charge that will be involved in resonance with the pi electrons of the benzene. My dear students, now this resonance that keeps on going, and the positive charge keeps on changing its position on the benzene. Finally, The electrons, they will move back to their original position, and in this way, my dear students, there are again five resonating structures which are produced, but in this case the positive charge is resonating with the pi electrons of the benzene, and you can see that in this resonance even the ortho and para position that becomes positive. When ortho and para positions will become positive, then my dear students, the deactivation of the benzene starts. So meta directors are basically electron withdrawing groups. When they withdraw the electrons from the benzene ring, the nucleophilicity of the benzene decreases and its reactivity towards electrophiles decreases. Therefore, they are all called as the deactivators. They are all deactivators. Now, my dear students, when some meta directing group that is attached to the benzene, it is electron withdrawing group. It withdraws the electron from the benzene and it makes the ortho and para positions positive. When ortho and para positions they become positive, then any electrophile which itself is positive, it will be repelled by the ortho and para positions. So it will be having only option to attack on the meta position and it will get attached with the meta position and they will be called as the meta directors. My dear students, there are so many examples of the meta directors like the key atom, if it is less electronegative as compared to the peripheral atoms, then in that group that will always be a meta director. Just like the NO2 group, in which nitrogen is the key atom and which is least electronegative in this complete group. So that will be a meta director. Similarly, CN group, the key atom is less electronegative than peripheral atom, so that should be a meta director. Carboxyl group, sulfonic acid group, formyl group, my dear students, keto group, these are all the meta directing groups, and my dear students, they are all basically deactivators. They are all deactivators because they will deactivate the benzene ring and the attack of the second electrophile that will become very difficult. So, my dear students, this was all about the ortho and para directors and meta directors and how the first substituent affects the activity and orientation of the second substituent. And my dear students, lastly, for example, if we have toluene in which the methyl group that is attached with the benzene, in that case, my dear students, there is no bond resonance, and that is called as the hyperconjugation. So when there will be no bond resonance, which is called as the hyperconjugation, in that this carbon hydrogen bond will be shifted here and this bond is shifted at this position, so this hydrogen will get positive, here will be double bond and this corner will get negative. And again, my dear students, in the same way as we have already discussed in case of the phenol, there will be resonance between the negative charge and pi electrons, and finally that will move back, and you will again get the toluene. So these are again the 5 resonance structures in which you can see that when some methyl group or any alkyl group is attached to the benzene, the carbon has no lone pair of the electrons to donate to benzene ring. Rather, in this hyperconjugation or no bond resonance will be there. So all alkyl groups, they activate the benzene by hyperconjugation or no bond resonance. And the hyperconjugation effect that makes the alkyl groups the weak activators. They do activate the benzene ring, but they are the weak activators. Now, my dear students, lastly, and the very important point, that what should be the order of the reactivity? If benzene has some ortho and para director, which is electron donating, then that should be having maximum reactivity. Then, my dear students, benzene. Then, if there is some halobenzene, because the halogen group, they will be weak deactivating. And then, my dear students, if there is some meta director attached to the benzene. So the maximum reactivity will be of the benzene having ortho and para director, then benzene, then halobenzene, and least reactivity should be of a benzene with which some meta director is attached. Let us take an example. Suppose that we have a benzene in which methyl group is attached. It is activator as well as the ortho para directing. So toluene will be maximum reactive. It will be more reactive than benzene. And then, my dear students, the chlorobenzene, that should be less reactive than benzene. And if we have nitrobenzene, then that should show the minimum reactivity. So in this way, you can also predict the reactivity of the different substituted benzenes. So that was all about the effect of substituent on further substitution. We have discussed in detail the ortho and para directors and meta directors, and I am very much hopeful that this lecture will be very helpful for you people. In case you find any problem, you can ask in the comment section. I'm gonna definitely answer that. Till then, take care.